In this lesson, we're going to be talking about the DNS protocol. DNS, of course, is the domain name system, and DNS is a way of looking up IP addresses from host names. Well, why do we need to do that? Because the computer can't actually use the host names that we use, which look more or less like English. www.microsoft.com, for example. We would have a website or a web address that's easy for us to remember, as opposed to the IP address that the computer actually needs to be able to make the connection. Because we can't remember IP addresses easily, we need host names to be able to go to and domain names to be able to go to. So as a result, we need some system that's capable of doing that lookup for us. DNS actually is capable of handling several different functions, one of which is to look up an IP address from a host name. Another one is to look up a host name from an IP address. I've got a packet capture here where we've got some DNS packets. Here's the DNS query, and you can see that it sits on top of UDP. Now, why does it sit on top of UDP? The reason it sits on top of UDP is I don't actually want to take the time to establish a connection to a DNS server. What I want is to have multiple DNS servers, and I'm going to just fire a query out to the first server. If I don't get a response in a reasonable amount of time, I'm going to fire a query out to my second server, and so on until I get a response. Because we're not connection-oriented, it doesn't really matter whether my first DNS server responds after I've sent the request to the second server, because if I get the response from the second server, I've already got the query answered, so I'm just going to discard the second reply, and I'm going to go with the first reply that I get. Here's where we're doing a query. So again, it's on top of UDP. And here's actually the DNS query itself. So we've got some flags here saying this is a standard query. And we've got one question here. I could actually have multiple questions, but I've only got one question. And what's my query? Well, my query is I've got a host name here. And what I want is a host address. So I'm doing an A record lookup. So there are several records that DNS supports. The A record or address record is one of them. So I want the IP address based on this particular host name. I could also do a reverse lookup of the IP address and get a host name from it. So here's actually where we've got the reply. You can see the DNS response. And we've got flags that indicate this is a response to a query. Recursion is desired, recursion is available. The server is capable of doing recursive queries. Now, some servers may actually not be able to do recursive queries, meaning they can't go to the root servers and be able to do lookups. The only thing those servers are capable of doing is responding about the particular DNS entries that they know about, the host names and the IP addresses that they have been configured with. So here's the query. We are looking again for www.google.com. We are looking for a host address from this host name. Here's actually my answer. In this case, I've actually got several different replies. There are several IP addresses that match this particular host name. You can see that we've got the same information here on all of them, of course, other than the address. So I've got the name, and it's an A record. I've got a time to live, which means this is how long this data is going to be considered good before you really need to ask again. The data length is actually 4 bytes. I'm going to copy this value here because I'm going to do a reverse lookup on it. So you can see all of this information, and this is all of the different IP addresses that match this particular host name. Now, we can look at another lookup here, and this is just a simple lookup of a web server. Looks like we're actually going to get 2 replies. One says it's a CNAME, which is a canonical name or an alias. The primary name is washere.com. Now we're going to look up was here and find that it actually has this IP address. We looked up www.washere.com, discovered it was an alias for washere.com, and looked up washere.com, and now we've got the IP address. What I can do is do a reverse lookup on the IP address 74.125.131.103. So I've done a reverse lookup, and that's what this indicates here. The PTR says I really want the name, the host name of this IP address. What I have discovered here is that there is no host name for this IP address, so there's no reverse entry. There's no way of looking up a host name for this particular IP address. Just going to verify that with another tool here. This tool indicates that we've got a host name of vc-in-f103.1e100.net, which is not actually what we got using dig. So host actually gives me a slightly different response. But what I can do is do reverse queries and get host names from IP addresses. And of course, what you'll commonly use is DNS to get IP addresses from host names. So that's what DNS looks like, both from a functional perspective as well as a protocol perspective.